Hello everyone, this is another workshop and we're going to talk about classes and how to define them. The easiest way to define classes in Scala, unlike Java, almost like Java, is to start with the keyword class and then the name of the class. That's all kind of what you have to do. You don't have to do parentheses like you would have done in Java. But you can add them, but you don't have to. So now if I'm going to run this in my worksheet, and I'm gonna wait a bit because always initially the workshop takes a long time to compile in IntelliJ. It's gonna tell me you have defined the class duck, and now let's start. So the next thing we're gonna do is to define another class, and I want to define it constructor. And how do I do that in Scala? Well, the easiest way is to just put a parenthesis there immediately after the class name, and that means you're starting to declare the constructor. Constructor can take arguments just like any other constructor, so I'm gonna pass in a name, which is a string, and a nickname, which is also a string. So these two variables are the arguments for the initial constructor, and I'm gonna start defining things in my class. I could define fields and methods, but whatever is outside of a field definition and a method definition is actually inside the initial constructor. So if I'm gonna print line, because I can do that inside here, and I can say print line inside the constructor, this line will print whenever you're gonna instantiate this class. Whenever you're gonna say new class malert, it's gonna print that one because it's inside the constructor, the initial constructor. And I'm gonna define the field, and it's gonna be called color, and I'm defining it with a val because it's immutable. I could define it with a var as well. It doesn't if I'm gonna put a var there, that means I can basically change it. But for now, this is the color. And an interesting fact here, you can just start if you put a val, you'll have to give it a value, right, once you declare it. So I can say, okay, if the name is Ducky, the one that I'm being given inside the initial constructor, and it's interesting that you can access those fields here, but kind of in a way, if it's not a method definition, is kind of in an initial constructor. So you have access to those two fields, and say if name is Ducky, then the color will be red. If it's iffy, then the color will be pink. And oh well, here is the if construct also, if you haven't seen it yet. It's similar to the Java one. You have if, else if, else you don't have a then part, and whatever you're gonna return here is gonna be the value of the color. You don't really need to give it a type to the color because it will infer it, but just so that we can see it nicely. Now I'm declaring the duck. The duck is a new Muller duck, and I need to give it a name, and I'm gonna choose Ducky, and the nickname, and I'm gonna choose Ducky the duck. That will be the nickname. And this is something that I can run, and it tells me that the duck is a Muller duck, and you can see it printed that print line there inside the constructor, so that you know that you are inside the constructor. Now I want to see what is available for me from the duck, right? I mean, I know I declared that instance variable color. So I want to see, oh, can I print it? Yes, it's interesting that I can. And I can run this again and it will say me color is red. So, you know, the other two, the name and the nickname, are not available because they're actually only arguments to the constructor, right? And as you can see, I have equals, I have hash code, I have to string, you know, the usual thing that all Java classes also have. So it's not different at all. And because I declared it a val, I cannot actually give it another color. So if I say another, it will immediately complain and say the error is reassignment to val. So I could always change it to a var. And if I put it a var, then it will still be an instance variable, but you know, I can do this. The color can be another. Now, it is a good practice to not have instance variables that are mutable, so that can change value, and just have your, you know, class with a constructor, and once you constructed it, it doesn't change anymore. Of course, that is not always something that you can do, or maybe wanna do, but you should strive for that. And now, what happens if I wanna have this name and nickname as instance variables? And as you can remember, in Java, you would have to you know, declare them as fields. There will be private fields, and then you'll have getters and setters, and then in the constructor you will initialize them. Well, in Scala it's much easier, because what you can do is put a val there, like in the definition of this constructor, and what it'll do is it will create automatically some methods called name and nickname, that you can access these fields. So I know initially you might think that name and nickname will be, let's say, your variables, but actually create some default methods, and they're not the default methods like you will see like the Java bin standard, like with get name, get nickname. But you can do that. So if you would like to do that, if you like that you have a getter and a setter, like with get name and get nickname, all you need to do is add this annotation, Scala reflect bin property, and now you can see I have a get name, and I also have the other one, name, which is interesting that it still remains there, but you know, for the sake of Java bin standards, you can do that. Now you can see that I only have a get name, I don't have a setter. And you might wonder, why is that? Well, the is a val, so I cannot reassign it. Why would I need a setter to reassign it? But you can, let's say, change that one, and you can say, oh, actually this is a var. I can always change my nickname, because you know the duck can grow and become somebody else. So I can say, okay, this is a bin property, so it will automatically you know, create me a setter. As you can see, I have a getter and a setter. So now I can set the nickname to somebody else, to something else. and I can set it to the new nickname. And now that I'm thinking about it, I'm gonna declare a method. So this class will have a method, and I'm gonna declare. What can I declare first? I'm gonna overwrite the toString method, and the easiest way to overwrite it is to use this overwrite construct. And I'm gonna define the toString here, and I'm gonna say a DAC by the name, and I'm gonna get it the name. I can always say this name, but you don't have to, just like in Java actually. And the color will be color. And what else do I have beside name? I have a nickname, and I'm gonna add that one also. And I could say print line me this. And now I'm waiting for it to compile, and oops, I have lots of errors. Now I'm wondering, what did I do wrong here? Because I'm quite surprised that I have errors. But I have a feeling this has to do with the override of toString, because it doesn't really like that everything is on one separate line. Because it says unary plus is not a member of Java lang string. You can define string on multiple lines using the tree code notation, but we maybe should talk about it later. And now the easiest thing to do is just to put everything on one line. If some of you encounter this problem, maybe you can leave a comment by this video and tell me what did I do wrong there. That was an interesting error. Now if I'm running this, should be fine. As you can see, it says the duck when I'm constructed it, a duck by the name Ducky and color red and nickname Ducky. So because now it won't print it when I'm declare it, the repo will automatically call the toString method that I created. Now, what else can I do to this class? I think I can declare, let's say, a method. And of course, there's a lot of talk about methods and functions, and this is the one thing that I wanted to mention, like the difference between methods and functions. So I am defining a canSing method, and this is an instance method, and I'm going to ask myself if name is Ducky. I'm wondering if Ducky can sing, and says I can squeak. Yeah, that's a very good thing. And if the name is Iffy, I can quack. Otherwise I'm mute. Yeah, I don't know how to sing otherwise. So this is kind of method definition. Of course, you can, you know, put a parenthesis there, say what the this method would return. If it actually returns something, maybe it's a method that doesn't return and just prints line. But you know, this is the main way to define this method, and I can call it I can sing. And now, you know, I can run this, and let's see what happens if I run this, because I have a feeling that it will give me an error. Yes, and the error says not enough method arguments for method apply. So it complains that it doesn't have an apply method. Interesting, because you would have thought, okay, it's a method, so then it's a function kind of, but actually it's not, because a function will be it's actually an object that extends the trait function 0, function 1, function 2, but a class method, an instance method, does not extend that one. So it doesn't have an apply method, because it's not an object. And that is the main reason why you cannot do those parentheses there. You cannot say apply me this. You cannot call the apply method because it doesn't exist. And that is one of the main differences that you need to remember when you're dealing with instance methods. They do not extend the function trait. Now if I'm gonna give it, I'm gonna say, okay, this method takes a parameter, a param, right? Then I can call it down there with I can sing with a parameter, and I give it the name of the duck. So these methods that are instance methods are basically almost exactly the same as in Java, right? And they are not functions, so it's a good thing to remember. What happens if I did want to define a function there? Well, first of all, let me say just one thing. What it means if I declare this this method is that every time I'm calling it, it gets evaluated, so it gets executed, basically. If I will want to declare a function here, I will have to do it anonymously, so I'll have to declare an anonymous function, and so that it is accessible from outside, I have to give it I have to assign it to a variable. So I'm gonna say can fly, well actually I'm doing something totally different. I'm declaring another instance method called can fly, and this can fly, as I said before, you do not have to you cannot do the empty parentheses there. Remember, when you get weird messages or weird errors that you should think, what's going on there? Is that because it's an instance method, it doesn't have the apply method because it does not extend the trait. And now we can declare an anonymous function, and I'm gonna say val anonym is the anonymous function that doesn't take any argument, and it will return me a string plus the name of the duck. And now what happens next might shock you a bit. So if I'm gonna say the duck dot anonym, this will return something interesting. It will return a function. So it will say anonym is actually an object, and the object type is function 0. So this val holds a function, and if I don't do the parentheses, then that means I'm not applying the function. What also happens is that whenever you're declaring a duck, this function gets evaluated and gets passed to the val. So the val will have the value of the function, and in order to call that function over and over again, you have to put a parenthesis in. So now you're calling the apply method the syntactic sugar, and now that part will tell me something else. It won't be the function. It will tell me a string ducky. So that was kind of it for this first part, and see you for the next part where we're gonna talk about multiple constructors and so on. Thanks for